So we need k hat and we need the line of nodes. All right, line of nodes, which is x1 hat, expressed in terms of the body. So I guess I'm recording. Yep. So let's do complete set of states. K hat is equal to, it is easier, it turns out, to go from, in the sense that it's easier to start here with x2 in this case and go back and then express everything in terms of x3. So the way we're doing is we get k hat, get it in x2, and then get x2s and x3s. So k hat is x2 k hat dot k hat, project, and basis set, plus y2 dot k hat, y2 hat, plus z2 dot k hat, and this is then z2 hat. Okay, let's look at x2 k hat. Well, this is a lovely thing that comes out. x2 dot k hat is the same as x1 dot k hat because I'm circling here. x2 is equal to x1. There is no k hat in x1, and how do I know that? Because x1 is right here. I'm drawing an arrow to it, pointing to it from the left. There's no k hat in there. By the way, there's no k hat in y1 either, but that's no big deal. We don't need that one at the moment. So this comes out to be 0. So our next term will be plus. Now let's have a look at y2 dot k hat. Here's y2. I'm pointing an arrow to it, dot k hat. y2 is in fact y1 cosine theta plus z1 sine theta. And as I just pointed out, I'm sticking an arrow next to it. This was much easier in class when I could, but you get the drift, you've seen it. y1, which I just have in there, has no k hat in it. But there's another piece, there's a z1, and z1 is in fact k hat. So when I do y2 dot k hat here, I'm going to get, y2 dot k hat here, I'm going to get sine theta y2. Because here's y2 hat, there's z1, z1 is the same as k hat, and there's my sine theta. And then this guy is very simple because z1, which I'm underlining with a wiggly line, is the same as k hat. So this is z2, which is equal to this guy, comes out just to give me a cosine. Z2 again, z2 dot k hat, there's none of that in there, so it's only z1, which is k hat, and I have a cosine. So I have here z2 hat. So there's k hat for us. And this now is simple. And the reason it's simple is because y2 and z2 are known in terms of x3. So if I want to solve for y2, call this equation 1, call this equation 2. Suppose I want to solve for y2 in terms of the bodies. If I want y2, I want to get rid of x. No, there's no x2 and y2 here. So if I want to get rid of y2, I can multiply. I want to get rid of x2, sorry. If I want to get rid of x2, I can multiply the top equation 1 by sine and the second equation by cosine and add them. The y2s have factors of sine squared and cosine squared, so that comes out beautifully. So I have now sine theta, y2 hat, just add them together, is x3 hat, I think that's x3 hat sine theta, which is x body sine psi, not theta, plus, and then that's going to be y body cosine psi. And then I have plus cosine theta, and z2 is z body, right here. Tap, 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 z body. So we're done with k hat. Now the line of nodes, so that's the first vector we need. The line of nodes, which is equivalent to x1 hat, we do the same thing. Get x2 hat dot x1 hat. We've done this enough times that this expansion of complete set that I'm hoping you start to at least appreciate the power of the idea. It's absolutely remarkable. You can do this. The principle of it is astounding to me. Okay, so x1 dot x2, these are the same. because remember back here, x1 and x2 are the same. The line of, you rotate and you rotate back. Line of nodes is a line of nodes. So this comes out to be, that comes out to be 1. So that's just x2 hat. And then we know that y1, y2 dot x1, let's go find y2. y2 is here, dot x1. You see there is nothing in there. y2 dot x1 is back here. Here's x1. And there's 0 overlap between those two. So that comes out to be 0. And then z2 dot z1 is just going to give me 0 as well. z2 dot x1, sorry. This is x, I said that can't be 0. Here's x1. z2 dot x1 is 0. How do I know that? Where's z2? z2 is here. It's composed of y1 and z1. y1 and z1 give me nothing. Don't have any x in it. So that gives me 0 as well. And I now, if I want x2, should be very quick and easy to get, because if I want x2 hat, I go back here to equation, tapping, 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 equation 1, equation 2. If I want to get x2, I eliminate y2 here and here. So I multiply the top one by cosine and the bottom one by sine and subtract. So I will get x2 hat will be equal to multiply the top one by cosine psi, x body hat minus sine psi y body hat, and that's x. And I know that this is back here. This is now, yeah, that's it. Okay. So finally, what I have is, I got it all. Okay. Do I have it all? Yeah, I think so. So this is then omega finally is equal to, now I'm going to find all my x's, my x bodies. My x body is, for the k hat, my x body is here, sine theta, sine psi. My line of nodes contribution is just cosine psi. So that is plus theta dot. Remember, the line of nodes goes with theta dot. I don't need lambda hat anymore. Now this is cosine psi. And that's x body. And then I have here, let's find y body. Y body is right there. So that is sine theta, cosine psi. That's the k hat one, so it goes with phi dot. Let's find the y body for line of nodes, which is that one here, minus theta dot sine psi, y body. And then, oh, there's a plus there, not an equals. And then plus, let's find the z body. The z body is here, cosine. And we already had the one left over from the very beginning, from here, which is omega psi, which is psi dot. So that is phi dot cosine theta. And then that'll be plus psi dot zb. So again, this is a convenient form because, and somebody should say this out loud, we can't access omega 1, omega 2, omega 3 inside the body very simply. We can look from the outside though and see the top. We can see the top leaned over at an angle theta. We can see the top spinning. In fact, we can measure how fast it's going. We can measure this if we want to, and we can measure this. So us sitting out here, we get the answer fairly quickly. So that's the connection that doesn't use the pictures and the text and doesn't use any of the other stuff. It's a straight formal derivation requiring only you keep track of vector analysis and have just a basic understanding of what a shadow of a projection is onto a plane for a particular unit vector when you lean it over. It doesn't require anything, and uses rigor as opposed to hand waving, in my opinion. All right, we'll stop there.